Good day. We are going to tackle about experimental errors to be discussed by Cantilang John Paul, Nato Francesca Sai, and Pelayo Andrei. Next slide. Experimental error is the difference between a measurement and the true value or between two measured values. So, experimental error itself is measured by its accuracy and precision. Accuracy measures how close a measured value is to the true value or accepted value. Next slide. Here are the types of experimental errors. First is systematic error, second, random error, and last is human error. Systematic error. Systematic errors have an identifiable cause, produce results that are consistently too high or low, and in theory, can be eliminated. There are four kinds of systematic errors. First is instrumental. When an instrument itself is flawed and provides inaccurate readings, example, a thermometer that registered 102 instead of 100 in boiling water bring results that were too high. Second is observational. When the observer incorrectly reads a measurement, example, a, a researcher may be standing at an angle rather than straight on when reading the weight on a scale. As a result, he consistently reads the scale in a way that reflects that angle. Next. Third is environmental. When problems in the lab surroundings lead to the inaccurate results, for example, an experiment involving organic material may be affected if change in humidity in the lab are not controlled. And last, theoretical, when an instrument itself is flawed and provides inaccurate readings. In an experiment testing gravity's effect on acceleration, the effect of air friction, which slightly affects the acceleration rate, may not be included in the calculation. So next, how we recognize systematic error. Systematic errors can also be detected by measuring already known quantities. For example, a spectrometer fitted with a diffraction grating may be checked by using it to measure the wavelength of the D lines of the sodium electromagnetic spectrum, which are at 600 nanometer and 589.6 nanometer. How can we minimize systematic error? Systematic error can be minimized by routinely calibrating equipment, using controls in experiment, warming up instruments prior to taking readings, and comparing values against standards. While random errors can be minimized by increasing sample size and averaging data, it's harder to compensate for systematic error. So, the second type of experimental errors is random errors to be discussed by John Paul.
Random errors. Random errors are caused by unknown or unpredictable changes in the environment, lead to random fluctuations in measurement. About one half of the measurements will be too high and one half too low. It does not always have sources that are identifiable. Random errors can also be often qualified by statistical analysis. Two major types of random errors. First one is observational. When the judgment of an observer leads to random, rather than consistent inaccuracies. Example of this is when a researcher reading the weight on a scale records measurement to the smallest division. Random error suggests that over time, the researcher's judgment is inconsistent. The individual will record some measurements that are too low and some that are too high. The next major type of random error is experimental. When there are unpredictable changes in environmental conditions, such as temperature, mechanical vibrations, and etc. Example of this is a piece of electrical equipment may have unpredictable noise that affects the result. The next will be human error.
So human error. What is human error? In a chemical analysis is any action or lack thereof that leads to exceeding the tolerances of the conditions required for the normative work of the measuring or testing chemical analytical system with which the human interacts. So here are some examples of human error. Spilling or sloppiness, dropping the equipment, bad calculations, doing math incorrectly or using the wrong formula, reading a measuring device incorrectly, thermometer or balance, not clearing the equipment, using the wrong chemical, not following the planned procedure. Next slide, please. So, how can we minimize human error? So, we can minimize the human error by customizing and automating a series of actions and events that occur in the lab, and creating automated workflows can be reduce human errors considerably. In addition, processes automation also helps reduce human errors that occur when processes are done manually. That's all. Thank you.
Yun na yun, cut na dun.